Asphalt mix is an engineered product for pavement applications composed of aggregate, binder, air, and sometimes chemical additives or modifiers. To achieve optimal performance, a job mix formula specifies the precise proportions of these ingredients, ensuring sufficient load capacity and resistance to rutting, cracking, skidding, and moisture damage. Let's look at how asphalt ingredients impact a mix design and the resulting job mix formula. Asphalt binder, or bitumen, is produced by refining crude oil. It binds aggregate to create asphalt pavement, stabilizing it to prevent rutting while remaining flexible to resist cracking. The binder influences pavement stiffness, temperature resistance, and ductility, and must meet FAA requirements per ASTM D6373. A performance grade 64-22 binder performs well between 64 and -22 degrees Celsius. Adjustments to the asphalt binder grade, called grade bumping, may be needed for airfield pavements that must withstand slow or stationary traffic. FAA construction specification P401 provides the required grade bumps based on the aircraft gross weight and pavement use. Binder grade bumping may require polymer modification, which will improve the asphalt mixture's rutting resistance. The improvement depends on the binder's properties and the mix's volumetrics. Aggregate typically consists of crushed or natural stone and sand, and sometimes mineral filler. The type of aggregate and the distribution of particle sizes, or gradation, affect pavement constructability and performance. Specifications may vary for aggregate sizes. The FAA defines coarse aggregate as material retained on a number 4 sieve with no particles over 1 inch. Fine aggregate passes through the number 4 sieve. The maximum density line, or MDL, separates fine-graded from coarse-graded mixes based on gradation. Fine-graded mixes with more sand-sized particles plot above the MDL, while coarse-graded ones plot below. Airfield mixes are typically fine-graded. Agencies such as the FAA may also set upper and lower limits to further control the material. Aggregates possess many characteristics other than gradation that influence asphalt mixture performance. For example, aggregate angularity, clay content, and the presence of flat and elongated particles all impact stability. Other aggregate characteristics identify specific gravity, absorption, toughness, and soundness as important for durability. Another ingredient to consider is reclaimed asphalt pavement. RAP is produced from milling or crushing existing asphalt pavement and screening it to an appropriate size. It consists of the same components as a virgin mixture and can be readily incorporated into a job mix formula. RAP is more cost-effective than other materials, helps reduce landfill waste, and aids in conserving natural resources. RAP is not allowed in the surface lift of airfield pavements except in shoulders. Asphalt mixes require air voids to allow additional compaction under traffic and a slight amount of asphalt expansion due to temperature increases. Air voids are the small air spaces between coated aggregate particles. In a mix design, this is represented as percent air voids. The FAA specifies 3.5% laboratory air voids as a design target when developing a job mix formula. Other key metrics include the voids in mineral aggregate, VMA, and the voids filled with asphalt, VFA. VMA are the air void spaces that exist between the aggregate particles in a compacted paving mixture, VA, including spaces filled with asphalt, VBE. VFA is the percentage of voids in the compacted aggregate mass that are filled with asphalt. Choosing the right combination of materials and quantities will provide the best performance throughout a pavement's service life.